Lesson will mainly talk about very basics of composites, and in this lesson we'll talk about what is composites and their disadvantage and advantage. Alright, and in subsequent videos we'll talk about the types of matrix and the types of resin. Alright, Don, if you don't understand, you just anyway. So let's continue this one and then we'll see how. Okay. The best picture to explain what is composite is this picture. Okay, you have this particular material, and this gray color one that is protruding out is actually the protection. Some layering to protect the the inner stuff of the product. Alright, and these little lines, the yellow lines, we call this the resins or the reinforcement fibers. So the resin or the fibers, they are all talking about the same things. Alright, in case that you may find it weird, but anyway, the blue color one is the matrix. Okay, and the next layer is the resin. So in this manner, they're actually stacking up the resins and the matrix all together in this way. There are many ways to actually stack up the resins and the matrix and things like that, and we'll not go through that. But anyway, this is just the understanding. And therefore, by definitions, alright, two or more constituent materials, so meaning two or more different materials will merge together physically or chemically, alright, or both of them together, alright, to merge together and come out with a finished product. Alright, so for example, CF alloy, I don't know what is CF, anyway, or it's called carbon fiber alloy. Okay, so it's just two or more materials put together physically or chemically, alright, to come out a finished structure. However, two materials remain separate and distinct throughout the finished structure. Alright, so this is why the pictures over here, as you can see, this whole product is the finished structure. However, the resins and the matrix are separate apart, you see. So the matrix is the matrix, the resins is the resins. If you plug it out, you can see the resin clearly, you can see the matrix clearly, things like that. So after knowing what is composite, the definitions, if you want to memorize, alright, now we're going to talk about the matrix and the reinforcing agents. Alright, so I took on another photos where this squarish thing, alright, I don't know whether you can see this piece, this slice of the bread, alright, or whatever size of this thing is called the matrix. Alright, while this little cheese, alright, is your reinforcing agents or your fibers or your resins. There's many names for it. Alright, so the resin itself by itself is pretty soft, but and this softness could somewhat say ductility. Alright, so it's somewhat very ductile. It can absorb a lot of stress, while the component of the matrix itself is somewhat a little bit more strength, alright, more hard, so that it can protect the resin that is inside. So therefore, this is something like a sandwich. Alright, so on the top, the matrix is like a bread. Alright, 面包, and then the inside is the cheese or whatever, your ham, whatever. So inside is your resins and everything. Okay, so okay, I won't memorize this one. I'm not going to talk about it. But for the reinforcing agents, alright, they know that it's discontinuous, meaning it's not one line by one line. Alright, although some of it may be one line by one line, but think about it is because as you can see, this part over here is somewhat like this. You see, they are not very continuous. They are aligned in a way, but they are still not very continuous. Or if it's continuous, it's one straight line like that. Alright, so therefore something for you to take note. Next thing is that they can be formed in the form of fiber or fillers. Alright, the fillers in this case is talking about particles. Alright, you can use calcium carbonate, you can use whatever thing, alright, just to mix. Alright, so the fillers are just some particles that is trying to fill it in, you could say. Alright, while the fibers are just those long strands of stuff that you can see all along. Alright, in any of the case, the fiber or the fillers, they are just used to impart electrical or mechanical properties to enhance the matrix properties. So by far the matrix is just that piece of bread. Alright, while your fibers and fillers are just your cheese, your ham, to enhance the matrix, to enhance your bread. So if you have pure bread, then you eat the bread also not very nice. So you put your ham, your cheese, your tomato, your lettuce or whatever, happy can already. After knowing what is matrix and the resins or your fibers or whatever, now we talk about the variables of which influence your properties of your fiber reinforced plastic. Alright, FRP is your fiber. That means the fiber that I'm talking about, the fillers. Alright, reinforced. So fiber reinforced are just the fiber that reinforce your plastic. So your plastic is somewhat your matrix or whatever, I think. Anyway, it's just the meaning lah. So I think these are all the pure memorizing thing. I don't need to explain. So you just read it up yourself. Nonetheless, there's many other variables where you can also go to this website. Alright, and then you search for laminar tool. I mean, not search, but you just download the Excel sheet, or it can help you to process all the calculations if needed in the future or wherever. Okay, just to put it here. So you search for calculator for composite laminar, and then you go to this one. Alright, the blinking one right now. Okay, so there may be a term that call itself the engineering composite. Alright, the engineering composite by itself is just a multi-phase two or more material that is artificially engineered, and this means that it's just the composite itself. Alright, so when you talk about multi-phase material, yeah, they are also talking about composite, because composite itself have many phases. Alright, where you have two or more materials put together and things like that. So you have 3 or 4 or 5, then you just multi-phase all of the materials all together, and they are just artificially engineered. Okay, so this is the multi-phase concept that I think can be very useful, because composite itself is composite, but they often use multi-phase material. I don't know, but yeah. So this page, I believe, is just to inform that the composite itself is rather very light, because it's just the density itself is just heavier than wood, that's all, but it's much lighter than concrete, aluminum, of other steels or metals. Okay, so composite generally is lighter. Okay, and it has a huge range of tensile modulus to choose from. So how you mix it, you can mix it to the amount of tensile modulus you want. So you can artificially model your tensile modulus, okay, in order to artificially create your material that you desired and things like that. And nonetheless, the tensile strength is comparatively bigger. So with a varying tensile modulus, alright, you can also have a very high tensile strength in order to prevent breaking. Alright, so you will not break or spoil easily because the tensile strength is pretty high. Next thing you may ask is that what is tensile modulus? Alright, the tensile modulus by itself is actually, you can call this the elastic modulus, you can call it your Young modulus, you can call it your tensile modulus. So any of these names, elastic, Young, or tensile, are all talking about the same thing. Alright, while the tensile strength, you know, is a tensile strength. So your U strength, or your tensile or your Young modulus can be artificially made, alright, in order to become elastic or not, things like that. So it all depends on you. Or the tensile strength, given all this glass, aramid, carbon, boron, or whatever is your fibers. So the choice of the fibers will determine the choice of your strength and also your tensile modulus. Okay, so these are the things that I believe is very useful. So we have talked about what is composites already. Now we will also talk about the disadvantage and the advantage. Okay, it's just a short one, so I'll continue within this video. And therefore, the advantage of the composite itself is the ability to produce large curvature geometry, meaning you can create whatever geometry you want based on whatever, because it's own self, you laminate yourself. Alright, you laminate, alright, or you paste piece by piece the resins, your matrix all together by yourself. So you can also determine your own geometry by yourself. So it is good in terms of geometry, because metals, steels, everything, they cannot be molded in ways that is pretty much easier than much. So in other words, composite is much easier to create the geometry that you want better than metal comparatively. Okay, and it minimizes use of multiple parts, meaning if you want to have a metal, you will need your bolt and nuts. Alright, you need to calculate your strength required, whether will the bolt fail or not. Alright, and there's this bolt, so will this part fail also. Alright, so these are the processes in calculation that in calculating that. So therefore, when you're using composites, you are not calculating. You're only calculating the composite itself only. You're not calculating the the bolts and nuts, things like that already. So this is another advantage, all right, and therefore it reduces your assembly time and your cost, all right, and you can also tailor your materials. As I said earlier previously in the other slides, we talk about. Wait where's the slide? Give me a while. We talk about over this slide, alright, this one, or we say that we can own self mix our materials, alright. So we can mix our own materials for our own purposes. So therefore, you wouldn't want to. So you can design based on the particular strength that you want, and that's all. So you wouldn't waste any material. So it enables efficient materials utilization. And the materials is you buy already, and you straight away process at a component manufacturing stage. So when you manufacture your piece, your composite, you're also manufacturing your material already. So that is just it is, I think. Yeah, because your composite by itself is already a material. It's a composite material. So the composite material has its own material, a material for your matrix and a material for your resins. Alright. So therefore these are materials within materials. So all your materials is being processed at the component manufacturing stage where you manufacture your whatever component that you want. So your component is a material. So your component can be your. So if you want to manufacture a box, so your box is a component. The component itself is a composite, is a material, composite material. So this component will be placed inside maybe an aircraft. Alright. So this component belongs to this aircraft, where this aircraft is a bigger assembly, things like that. So these are the words that they are being used, I think. What I've been talking about is advantage of composite over metal. So you're comparing composite and metal. Okay, comparing composite and metal. Okay, and therefore it can be more stiffer, lighter, and more durable. Alright. But although metals have excellent strength and toughness combinations, but it is heavy, alright, and corrode, while your composite itself cannot corrode. So in some sense, composite is rather a very advisable choice, okay, which is lighter and more corrosive resistance, and often lack the toughness, because sometimes the fiber or the matrix may spoil and things like that. So these are things that you need to argue in the exams or whatever. So let's talk about the fiber reinforcement plastic composites. Alright, so you can own self read yourself, but the designer properties, this means that your properties is based on your designer. Alright, so if you want to design a certain properties, you design your own properties. So it's very custom made. So you can it's very good in this manner. So you can design your properties based on your needs. Alright, where metals, everything comes in a set of properties. Because sometimes you want a properties that is light, but however, if the material is light, it is not hard, then you need to find another material. However, if you have a composite, you can mix light and hard all together at once. So this is why composite is chosen. So resistance to fatigue damage with good damping. So the damping itself is to damp away the vibration if possible. Alright, most likely I will believe is the fibers. Alright, so if you have your matrix over here, you have your fibers. So fibers over here, they are all discontinuous. If you remember, they are all by itself, one piece by one piece by one piece by one piece. So these things over here, when vibrating, alright, this piece over here, this resin will move to here, and then after that you'll return back to its own position back here. Alright, things like that. So the vibration itself in the resin, in this fibers manner, alright, the fibers actually act as a good damping to damp away all the vibrations. So these vibrations will if you have vibrations, then you'll cause fatigue, things like that. The rest you own self read. Alright, but part consideration is that you can pre-assemble and prefabricate your own product. Meaning is that you straight away design. Let's say you want to design a wing, aircraft wing. Alright, the aircraft wing itself is a wing. So you straight away manufacture this wing, and then after that, this is the whole pre-assembled and prefabricated part. So this is the free. Not the free, but the pre. So you already assemble everything together at once already. So once you got the aircraft, the fuselage or the body of the aircraft, then you have some bolts or nuts, whatever, or glue, adhesive, alright, and then you just stick this thing onto here, and that's it. I don't know, anyhow whack only, but this is just the meaning of that lah. So you prefabricate, you pre-make your part, so into a part, so you can easily make the part out based on your composites and things like that. I think you know what I mean, but you won't memorize everything if you want to just memorize. And the next thing is the disadvantages. Properties depends on it has a poor mechanical properties transverse to the fibers. So meaning if you have this is your matrix, alright, your matrix, and then these are fibers. Alright, let's say if I have a matrix like this, and I have a fibers that is aligned in this manner. If you pull in this direction, they call this the longitudinal direction. If you pull in this manner, you call this the transverse direction. So apparently if you pull in this direction, alright, you are more stronger. However, you have poor strength in this transverse direction. This is just what it's trying to say. Okay. Well, the rest of the disadvantages, I think you can own self read it up. But for poor heat and fire resistance, alright, so it's not good for high temperatures applications. And therefore, the next thing is that why do aircraft still use composite, since that this is a poor heat and fire resistance? Alright, and therefore the answers is that I believe is that they add in a fire protection film, okay, on top of whatever protection that you are talking about. Alright, so within itself are all your composites, and after that you have a protection to protect against corrosion or whatever. Alright, and then after that you have a protection film to protect the whole structure, so that you have a fire resistant material. So if let's say they ask you, since composite is not fire resistant, and how come it is used for aircraft? So you can say that aircraft itself, the composites uses fire protection materials to add on to it to make it more fire resistance and things like that. So if you are keen to know more, you can go to Bright Hub Engineering and search for the types of reinforced concretes. Alright, talking about concretes for composites, and then other materials for composites, things like that, and then natural fibers and things like that. In terms of skills and training for composites manufacturing, you can also search, where do I search just now? You can search composite design skills, and then this one, the Gatsby. Alright, you can just check it out if you're free, in case that next time you want to design something that is related to composites, or composite textile or composite cloth, then you can also search for this in case that you may need anything about that. Alright, so I think this is the pretty much introduction to composites and the disadvantage and advantage of composites. So in the next video we'll talk about the types of matrix that are used and the types of resins in the subsequent videos. Alright.